Bismillahirrahmanirrahim. Dear student, my name is Zubair Awan, and this is our seventh lecture of artificial intelligence. If you do have any kind of question or any type of confusion in your mind, you can simply email me or you can WhatsApp me. I will definitely try to reply you regarding your query. So, without wasting time, we start our lecture. So, our today's lecture is regarding informed search and many other searches that we will discuss later on. This is informed search. So, what you consider about what is search? So far, have assumed that no non-goal state looks better than another. Like if we have nodes, different intermediate goal, uh, the state that is not representing the goal state is known as non-goal state. What is unrealistic? Even without knowing the road structure, some locations seem closer to the goal than another. This is unrealistic that we have if we have different states. So some states are near to the goal state and some states are far away from the goal state. So this is unrealistic. Some state of the puzzle seems closer to the goal than other. Makes sense to expand loser seems node first. So what is heuristic? You have to consider heuristic function is this is h of n gives an estimate of the distance from the end to goal. So h of n is equal to 0 for goal nodes. Actually this is height and this is node. Straight line distance from traveling problem. So if we have different states and we have different distances, then this would become straight line distance from traveling problem. If I demonstrate or I explain you from here, this is look, this is start state, that is h of a is equal to 9, h of b is equal to 8, h of c is equal to 9, h of d is equal to 6, and h of e is equal to 3, and h of f is equal to 0. The height of the final goal state will be 0. Typically assume that h is 0 at goal state. Yes, it is. We are adding something new to the problem. Actually, we are this was a problem and we are adding some few things more in this problem. Can use heuristic to decide which node to expand first. Yes. Greedy best search. This is another best first search. Values, we have A state, we have B state, we have D state, then we have E state, and we have F state, and this is goal state. So what is the name of this search is greedy best first search. Like it will gives us the best route from the start state to the final state. So here I repeat again, this is greedy best first search from state A to B, because this B was neglected because our goal destination was hid from on this site here. and this is F state, and this is the final state. Rapidly finds the optimal solution. This is the quality of greedy best first search. Bad example. This is a bad example of greedy of a greedy algorithm. Dear student, this is an another example of search, that is asterisk search. Let g of n be cost incurred already on path to n. Expand nodes with the lowest g of n plus h of n first. Here you can see the diagram. H of a is equal to 9. This has h of a is 9, h of b is equal to 5, h of d is equal to 6, h of e is equal to 3, and h of f is equal to 0. If h is equal to 0 everywhere, then just uniform search, cost search. What this is, we will explain here. Like, what is asterisk example? This is asterisk example. Like, we first start from we go state A, then we go to state D, then state E, and then state F. So, dear students, let's talk about what is admissibility. A heuristic is admissible if it never overestimates the distance to the goal. So the word never overestimates, like it do not gives us more distance than the real, then it is known as admissible. So straight line distance is admissible, cannot hope for anything better than a straight road to the goal. If you are traveling from one city to another city and you find the shortest distance, so that shortest distance would be the best solution, or that would be the optimal solution. Admissible heuristic means that asterisk is always optimistic. So what is the optimality of asterisk? If the heuristic is admissible, asterisk is optimal. If heuristic is admissible, asterisk is optimal. In the like I have already explained, that admissible means if it is giving a straight line, asterisk is optimal. Optimal means the best solution, in the sense that it will never return a suboptimal solution. Like it will not give you another good solution. The solution that it will give would be the best one, and that would be the last one. Dear student, this is iterative deepening asterisk. So one big backdraw of asterisk is the space requirements. Similar problem as uniform cost search that we have discussed in our previous slides. So asterisk required a big space to store its iteration or store its all the computation. This was our today's lecture. This was about the informed search, and hope you have understood that the one thing, keep in mind that have assumed that no non-goal state looks better than another. This is the theme of informed search. And here is heuristic gives an estimate of the distance from end to the goal. So um these two are the best lines that you have to remember in uh, all time, that what is heuristic and what is informed search. So this is all from our seventh lecture of artificial intelligence. Inshallah, we will meet in our next lecture. So till then, Allah Hafiz.